My dear friends, anyone are in live? Anyone is in live? Hello, my dear friends. Anyone is in live? Hello, my dear friends. Anyone? Good evening. Ketan, good evening. Good evening, good evening. Is the video and audio is clear? Ketan, is the video and audio is clear? Is the video and audio is clear for everyone? Good evening. Good evening. Good evening, Joshita. Good evening, Akshara. Right. 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 Now, in the last class, we have studied up to where we have studied? We have studied up to the left to right, what it will happen to the atomic size, and top to bottom, what it will happen to the atomic size. We have studied. Right? Now, in this lecture, we are going to see first of all, how to predict the size for the D block elements and top to bottom what it will happen, that all we are going to see in this lecture. Now in this lecture first I will explain about the which one. Once again I will recap the left to right what happened to the atomic size, top to bottom what happened to the atomic size. Next, and then after that we'll go to the ionization energy, electron affinity as well as electronegativity. Then after we'll do the questions. Right? Now, clear? Right. Now we'll move to the concept. My dear friend, first studies, then after the cricket. Actually, when I was at your age, I was so curious to watch the cricket as well as seeing. But good evening, Bindu. Good evening. Right. Now, 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 once we'll recap the last class what we have studied. Here in the last class we have seen what we have seen in the last session. Now the as the left to right when we move in the periodic table, the electron is adding in the same shell. When the electron is adding in the same shell, due to that what it will happen, nucleus charge is increasing. Due to that nucleus charge when it is increasing, what happens to the size? When the nucleus charge increases, here it will attract its valency electrons towards itself. Good evening, good evening. Now, that's the reason here you can see the number of protons increases, atomic radius decreases. Clear? This is about across the periods. Now, when we move from the top to bottom, here you can see, good evening, Srinitya, good evening. Now, here what it is happening, here when we move from the top to bottom, what it is happening, the electron is adding in the new shell. You can see the size of the shells are increasing when we are going from the down to top to bottom. Due to that what it is happening, atomic size is increasing. Due to that what it is happening, atomic size is increasing. So that we can say that left to right size, what? Left to right size decreases, top to bottom size increases. Actually, this one, next one, you can see here in the groups or in the periods, if you cross check for the chlorine and the sodium, chlorine it is having the 11 what 11 nuclear charge, and for the chlorine it is having the 17 nuclear charge. Due to that, good evening classical dancer, good evening Ashwant. Now, due to that, what it is happening? Due to that, the more the nuclear attraction, more will be the valency electrons will be attracted towards itself. Due to that, what happens? The orbit size will be decreased. Due to that, what will happen? Orbit size will be decreases. Right? Now, by that, we got to know that we got the one statement. That what is that one statement we got? Now, in periodic table, alright. In periodic table, left to right, if you go left to right, atomic size decreases. Right? In periodic table, top to bottom, atomic size increases. Clear? This is the two statements we got. So for the S block elements and the P block elements, S block elements and the P block elements, we will not get any confusion. But when we apply this general trend, when we apply this general trend to the D block elements, there we will get the problem. There, what it will happen? The many of the confusion, many of the students, they are getting the what difficulty in the D block elements. For the D block elements and the F block elements, whatever the general trend we got, that it is not satisfying. It is not satisfying. Why it is not satisfying? Now we'll see. Here, when we go for the D block elements, actually the D block elements, the size will be in this manner. From the scandium, titanium, vanadium, chromium, if you go, now the size order will be, we are getting in this manner. First keep on decreasing, after that it is increasing. Now why it is keep on increasing and why it is keep on decreasing? Now we'll see. Now my dear friends, be careful, listen carefully. If you are not at all understand, you just ask me, sir, I was not at all understand, can you repeat it once again? I am ready to repeat it. Okay? Don't be, just simply don't see the class. Actually, this is somewhat complicated. Somewhat it will be more you have to assume. If you understand, then it is well and good. You can get the questions very easily. But if you are not able to understand, means it will make you a lot of confusion. So, now if you are getting any confusion, directly you just text in the chat so that I can start it from the once again. Right? Now, for the D block elements, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and the zinc. This is a left to right. If you go, we used to think that size decreases according to our trend, but actually this is wrong. Why actually this is wrong? Because here this is our nucleus, right? Now, in this nucleus, for the D block elements, for the scandium, already 2 electrons will be in the S. 2 electrons will be in the S. And for the scandium, here it will be the 3D, right? Here it will be the 3D. Then, when the 3D electron, when we have added in the 3D, at the same way here the nuclear charge also increases. For the scandium it will become the 21. Now when it go for the titanium it will become the 22. It will become the 22. Now you can see already the valency shell, we are having the 2 electrons. When we added the electron in the 3D, nuclear charge is increasing. As the same way, when we added the electron in the 3D, this outermost electron and the inner shell, when we added the electron in the inner shell, here the nuclear charge is increasing. Due to that nuclear charge, what it will do, this nuclear charge will want to attract this valency electron. Towards itself. This, when we add the electron in the inner shell, what will happen? Obviously, nuclear charge increases. Atomic number 21, 21 protons. Atomic number 22, 22 protons. Atomic number 23, 23 protons means nuclear charge. Higher the nuclear charge, the valence electron want to attract towards itself. But what it will do, nuclear charge increasing, at the same time the inner electron is repelling the valence electron. Inner electron is repelling the valence electron. Due to that counterbalancing between the size and variation we are getting. Clear? Is it clear up to now? ఇక్కడ చూడండి. Now for the scandium, what it is happened? Good evening, Subhana. Good evening. Now you can see here. Here what it is happening? First of all, for the scandium case, the electron in the 3D, right? This is a S. Already the S electrons are adding. Now, as the inner d electrons increases, nuclear charge also increases, right? Scandium 21, titanium 22, 23, 24, 25. Like that, nuclear charge also increasing. As the nuclear charge increases, what it is happen? This nucleus want to attract the valence electron towards itself. But inner electron, what it will do? It will repel that electron to not to attract to the nucleus. Due to that, what happens? Size increases, right? Due to the repulsion, what happens? Size increases. That's the reason here two factors are counterbalancing. When the inner electron added, nucleus charge increases, and what? Valence electrons, when it is attracting, these inner electrons are repelling. Okay? How they are repelling? Now with this help of this picture, now you can see. Here you can see. Now, is the picture is clear, everyone? Is this picture is clear? Now, is this picture is clear or should I enlarge it? Right? Now. Right. Good. Now. Okay. Fine. Now you see. Here, how the inner electrons are attracting, how the inner electrons are repelling, how the inner electrons are attracting, and how the inner electrons are repelling. Now you see. Here, this is one. Now, you can see. This is the 1d orbital electron, n minus 1d. This is a which electrons? 4s2 electrons. For the scandium, here the atomic number is 21 means 21 protons will be there. Then here these are the outer electrons, 4s2 electrons. These are the 4s2 electrons. Now this is a 3d 1 electron. Now as the inner electrons increases, what it is happening? Nucleus charges also increases. Nucleus charges increases means this valence electron want to attract towards the nucleus. You can see these arrows. You can see at the same time this electron is repelling. You can see the picture. These inner electrons are repelling. These inner electrons are repelling the valence electron. So both the cases you have to counterbalance and you have to check the size for the d block elements. This is the one concept that it is having the exceptional size in for the d block elements. This is the main reason for the, you can see with the picture it will be clear for you. It will be clear for you with the picture. Now you can see. See. Here the inner electrons are repelling the outer electron. As the same way, nucleus is attracting the outer electron. Inner electrons increases, outer electron will repel. As the same way, nucleus want to attract, but inner electron want to repel. Due to that, the size variation we got. I hope it is clear for you for the d block element. Still you are having any confusion? Or is it clear? This is up to which one? This is up to, this type of the variation is up to which one? Up to the manganese. So that's the reason the 3D series. Yes. Okay. Now here why we are having the, actually why the variation, no, why the variation in the size we got? Because here if the nuclear charge increases means valency electron want to attract towards the nucleus. you can see valency electrons want to attract toward the nucleus. Why? Nucleus charge is increasing. So that if the valency electrons increases, the inertial d orbital electrons, what they will do? Electron is negative charge, outermost electron is also negative charge. When they have coming closer, this inner electrons will be repel. Electron repulsion, right? Here, these two types of the counterbalancing will be there in the d block elements. Due to that size variation we will get in the d block elements. So with the nuclear charge increases, size want to decrease, but inner electrons is also increasing at the same time. Due to that repulsion, size is somewhat whatever we have expected to decrease, but it is not decreasing. Somewhat variation we are getting. That is only it is happening, right? Now due to that the 3D series elements. Now what is the size order we got? Now we'll see. Actually the size order we got, first is scandium, because here you can see 21 protons and 1 d electron and 2 valency electrons, right? When it comes to the titanium 22 nucleus, and here the S 2 electrons. Now inner D 2 electrons, right? Inner D 2 electrons. Now, but when it comes to the next, actually we have expected that next should be the vanadium, but here it will get the zinc. But why the zinc size has came? Because you can see what I said. Here nuclear charge increases. Here the nuclear charge is increases. Nuclear charge is for the zinc now it is 30 E. 30 plus 30 nuclear charge we are having. But inner electrons are also 10, right? Inner electrons are also 10. 1, 2. Now, due to the inner electrons, what you will do? These inner electrons will repel the outer electron very strongly. More the nuclear charge, okay. Then this want to be attracted toward the nucleus, but inner electrons are very nearer. These inner electrons are nearer. Due to that inner electrons repulsion, as well as these outer electrons are also will be repelled by the inner electron very strongly. Due to that repulsion, size will be increases, right? Due to that repulsion, both will be move away from them. Means that's the reason orbit size will be increases. That's the reason zinc is having the higher size than we expected. Then after that, we are having the vanadium. Then after that, chromium. Then after that, copper. Then after that, all are high. Vishal Raj high. Then after that, manganese and the rest all will have the equal size. Means when it comes to nickel, iron, cobalt and this all, what it will happen? Same. Nuclear charge and the valency electron repulsions will be counterbalances in this case. That's the reason it is having this size order. It is having this size order. I hope it is clear for you all. I hope it is clear for you all. Still you are having any confusion? I hope it is clear. I hope it is clear for all. Or still you are having any confusion? I hope it is clear for all. I hope it is clear for all. Right. Done. Now, next, when we move from the top to bottom, yes, good. Hi Radha, hi. When we move from the top to bottom, now when we move from the top to bottom, right? When we move from the top to bottom, now what is the actual trend? Top to bottom, atomic size should be increased. But here, what it has happened to the D block elements when we are moving from the top to bottom? For the D block elements, the top to bottom, it will be somewhat having the different. What it is having the somewhat different? Now here we are going to see. Top to bottom we have expected the atomic size should be increased. But when it comes to D block elements, atomic size from the 3D to 4D if you are going, it is increasing. Like titanium, zirconium, hafnium, okay, and rutherfordium. If you see the expected size, this is expected. The expected size is titanium, titanium less than zirconium less than hafnium less than rutherfordium. This is expected, but actually this is wrong. This is not the actual size order for the which one, for the D block elements when we are moving from the top to bottom in the group. Why, sir? Why it is not increasing like that means, now I will say. Now here we are going to see why it is not happening, what we have expected. Now in that expectation why we are not getting, now we'll see. Here when we move from the, this is a nucleus. Now just now what I said, here we have seen this one, right? Same, this is the same reason for this one also. Now what is the reason? Here if the s orbital electrons are there, s orbital electrons are nearer and it is small size, and as the valency electrons, this valency electrons, what it will do, this valency electrons when it want to attract towards the nucleus, if the inner electrons are protecting means they will repel strongly. If they are not protecting means they are not repelling that valency electron. Due to that the size variation we will get. The same thing it is happening for the D block elements. Now you see, this is n is equal to first period. For the first period we are having only s orbital electrons. What we are having? We are having only s orbital electrons. S orbital electron size is small, so the electrons are nearer, so it will shield the electron very shortly. Sir, what is the meaning of shielding? Means protecting of valency electron strongly. Protecting of valency electron strongly is known as a shielding effect. Okay, this s orbital electrons will protect the which one valency electron strongly. Next, when the n is equal to 2, this is a second period we are having s orbital electrons and as well as the p orbital electrons. P orbital electrons are also will shield or will protect the valence electron strongly. When it comes to the third period, but third period we are having S as well as P. But D block elements, D block size is somewhat higher, right? D block element or D orbital is somewhat high, right? Now due to that high size, what it is happening? This valency electrons, this D block elements, the electrons are somewhat far away from them. Now when the electrons are far away from them, now when it comes to the D block, when it comes to the fourth shell, F block elements will come, right? Now here the F block elements, electrons are more far away from them. Now you see, here this one electron, valency electron itself. This valency electron want to attract toward this nucleus. Now if this valency electron want to attract toward this nucleus, now you see here, when this valency electron is coming like this which orbital? F orbital electron is not protecting. So still the size decreases. Shell size decreases, right? Now again it will come to the D block. D block electron is also not protecting. When the D block electron is also not protecting means now still the size will decreases, right? In that manner it will be happen. Due to that what it will happen? We have expected the size is this much. But these valency electrons of this F orbital electrons and the D orbital electrons are not protected. F orbital electrons and the D orbital electrons are not protected. When the F orbital electrons and the D orbital electrons are not protected properly, then what happened? Now the size has decreases, right? Now you can, the size has reached here. The size has reached to here. That's the reason the whatever the expected size we have expected, but it is not getting in the which one? D block elements when we move from the top to bottom. Is it clear? Or still you are having any confusion? Is it clear or still you are having any confusion? Is it clear for everyone or still you are having any confusion? This is known as a shielding effect. This is known as a shielding effect or the screening effect. Screening effect order. Screening effect order. Right. Screening effect order means s orbital electrons will protect very strongly. P orbital protecting strongly is nothing but repelling the electron. That's it. Clear? Now P, now it is a D and it is a F. Now this is the screening effect order. Now what I want to explain, Bindu. Now nothing but here actually now here nothing is there. Here these are the f orbital electrons will be present in the fourth shell. These are the d orbital electrons. Now if the any valency electron if it is present, this valency electron want to attract towards the nucleus. If the electrons are nearer, that will be repel. But f orbital electrons are not nearer, so that valency electron is not repelling. Due to that, what happens? We have expected the size is this much. This much size we have expected, but actually the size it has came this much. Due to that, what happened? Top to bottom size increases we have expected, but it is decreasing because f orbital electrons and the d orbital electrons are not protecting strongly. That's it. Right? This is the screening effect. S and P will protect strongly. D and F poor screening. Okay? Right? Now, due to that, what happens? Now, for the which one? When we move from the okay, right. Now, this is a 3D series. Now, this is a 4D series. Now, this is a 5D series. Now, this is a 6D series. Now, 3D series will be start from the which period? Fourth period. This will be start from the fifth period. This will be start from the sixth period. This will be the start from the seventh period. Now, the fourth period, what are the elements we are having? Fourth period, we are having the 1s, 1s. Next, after the S, we are having the D. Then after the P. Here also S, D, P. Here S, F and D, P. Here S, F, D, P. In this manner, the electrons will be enter. Right? Now you can see. When we move from the 3D series to 4D series, here the which electrons? Same thing. Both are having the same shielding effect. S, D, P. So there is no any exception. So obviously the size will be increased. Size increases from the titanium to zirconium. But zirconium to hafnium, if you are going, zirconium it is having the which one? 6s2 electron. But 6s2 electron, what happens here? When we go from the hafnium for what happens? Hafnium, we are having the poor shielding of F electrons will be start. Then the poor shielding of F electrons are starting. Now we have expected the size for the hafnium is this much. This is for the which one? This size is for the, now whatever the size we got, this is for the zirconium. Then the hafnium size we have expected this much. Wait, hafnium size we have expected this much. These are the f orbital electrons. Now hafnium size we have expected this much, but due to the poor shielding, what happened? Now f orbital electrons are not protecting. Now the hafnium size, it has reached. Now hafnium it has reached to the same size of the zirconium. Now you see, in that manner, both the hafnium as well as the zirconium size has become almost nearer to the equal. Why? Poor shielding of the f orbital. Electrons are not protected. That's the reason zirconium and the hafnium size has become equal. Right? Done. Next, hafnium to the Rutherfordium. If you go, the same thing it will be happen. Here you can see, again here the f orbital electrons are there. F orbital, it will not be protected. Still, the size will be somewhat decreases. Here the size will be decreases. Is it clear? In that manner it will be happen. Due to the poor shielding, and this type of the effect we call it as a lanthanide contraction. This type of the effect we call it as a which effect? Lanthanide contraction. Due to the lanthanide contraction, what it has happened? Now, whatever the expected size we have expected, but it is decreasing. It is not happening the same size what we have expected. I hope it is clear for you. Still you are having any confusion? Still you are having any confusion? If it is clear for you, we'll do some questions based on this one. We'll do some questions based on this one. Right. Now we'll do some questions based on the which one? No, we'll do some questions, right? Now the question is largest size among them. Largest size is asking. One is Cl minus, two is S minus 2, 3 is Na plus, 4 is F minus. Which is having the larger size? Which is having the larger size? Once again I have to explain. Nothing is there, ikkada SDP, ikkada SDPA. ఇక్కడ ఉన్న వాలెన్స్ ఎలక్ట్రాన్ ని ఎస్డిపి ప్రొటెక్ట్ చేస్తుంది. సో దానివల్ల ఏమైతుంది, టైటానియం నుంచి జెర్కోనియం పోతే సైజ్ ఇంక్రీజ్ అవుతుంది, ఎందుకంటే రెండు సేమే. కానీ జెర్కోనియం నుంచి ఆఫ్నియంకి పోతే ఆఫ్నియం సైజు పెద్దగా ఉండాలి, ఆఫ్నియం సైజు పెద్ద ఉండాలని మనం అనుకున్నాం. కానీ ఈ ఆఫ్నియం యొక్క వాలెన్సీ ఎలక్ట్రాన్స్ ఏవైతే ఉన్నాయో ఆ వాలెన్సీ ఎలక్ట్రాన్ న్యూక్లియస్ అట్రాక్ట్ చేస్తుంది. ఇక్కడ చూడండి, దిస్ ఈజ్ ద, ఇది జెర్కోనియం. ఓకే, మనం ఏమనుకున్నాం, ఆఫ్నియం సైజ్ ఇంత ఇంత పెద్దగా ఉంటుంది అని అనుకున్నాం. ఇది ఆఫ్నియం యొక్క వాలెన్సీ ఎలక్ట్రాన్, ఇది ఆఫ్నియం యొక్క సైజ్ ఇంత ఉండాలని మనం ఎక్స్పెక్ట్ చేసినాం. కానీ ఆఫ్నియం యొక్క వాలెన్సీ ఎలక్ట్రాన్ ఏదైతే ఉందో, ఈ ఆఫ్నియం వాలెన్సీ ఎలక్ట్రాన్ ఏం చేసింది అంటే, ఈ న్యూక్లియస్ అట్రాక్ట్ చేస్తున్నప్పుడు, ఈ న్యూక్లియస్ ఏదైతే వాలెన్సీ ఎలక్ట్రాన్ అట్రాక్ట్ చేస్తుందో, ఈ వాలెన్సీ ఎలక్ట్రాన్ ఏం చేస్తుందంటే ఇలా వచ్చేస్తుంది. ఇక్కడికి వచ్చేవరకు ఈ ఎఫ్ ఆర్బిటాల్ ఎలక్ట్రాన్స్ ఏవైతే ఉన్నాయో ఆ వాలెన్సీ ఎలక్ట్రాన్ ని ప్రొటెక్ట్ చేయడం లేదు. అంటే ప్రొటెక్ట్ చేయడం లేదంటే రిపల్ చేయడం లేదు. రిపల్ చేయకపోతే ఈ వాలెన్సీ న్యూక్లియస్ ఏం చేస్తుంది, ఇంకా అట్రాక్ట్ చేస్తుంది కదా, దానివల్ల ఇక్కడికి వచ్చి ఆగిపోతుంది. దానివల్ల ఇది ఏమైపోయింది, ఆఫ్నియం సైజ్ అయిపోయింది. ఆఫ్నియం సైజు జెర్కోనియం సైజు రెండు ఈక్వల్ గా అయిపోయినాయి కదా. ఇంకా ఇది ఇక్కడికి వస్తే ఏమవుతుంది, ఈ ఎలక్ట్రాన్ రిపల్ చేస్తాయి దాన్ని, అందుకనే దగ్గరికి రావు, ఇక్కడ వచ్చి ఆగిపోతుంది. ఇక్కడికి వచ్చి ఆగిపోయింది అంటే వాట్ డస్ ఇట్ మీన్, జెర్కోనియం కి ఆఫ్నియం కి ఈక్వల్ సైజ్ వచ్చేసింది కదా, జెర్కోనియం అండ్ ఆఫ్నియం కి ఈక్వల్ సైజ్ వచ్చేసింది కదా. అందుకే ద ఆర్డర్ విల్ బి టైటానియం లెస్ దాన్ జెర్కోనియం, జెర్కోనియం ఈక్వల్ టు ద ఆఫ్నియం, ఆఫ్నియం విల్ బి గ్రేటర్ దాన్ ఆర్ ఈక్వల్ టు ద రూథర్ఫోర్డియం. ఇలా వస్తుంది సైజ్ ఆర్డర్ ఫర్ ద డి బ్లాక్ ఎలిమెంట్స్. ఓకేనా? ఆర్ స్టిల్ యు ఆర్ హావింగ్ కన్ఫ్యూజన్? క్లియర్ అయినా ఇంకా కన్ఫ్యూజన్ ఉందా? క్లియర్ అయినా ఇంకా కన్ఫ్యూజన్ ఉందా? ఈజీ క్లియర్? రైట్. ఓకే, ఇక్కడ ఇప్పుడు చెప్పండి, నా క్వశ్చన్ కి ఆన్సర్ చెప్పండి. విచ్ ఈజ్ హావింగ్ ద హయ్యర్ సైజ్? దీనికి ఇది ఫస్ట్ క్వశ్చన్. సెకండ్ క్వశ్చన్, నో సైజ్ ఆర్డర్ ఫర్ I minus I plus 1, 2, 3. Among the 1 to 3 size order. Janaki Ram, ఇది ఈవినింగ్, గుడ్ ఈవినింగ్. Janaki Ram, ఇది గుడ్ ఈవినింగ్. ఓకే, what is the answer? What is the answer you got for this question? దీనికి ఆన్సర్ ఏంటి? దీనికి ఆన్సర్ ఏంటి? What is the answer for this question? Question number 1, what is the answer? Question number 2, what is the answer? Question number 1, what is the answer? Question number 2, what is the answer? Na? No, I was given the options, right? First one same with the option and the second one same with the option. First one same with the option, second one same with the option. Good evening Vishnu, you are late to the class. What is the size? Are you there? I was asking the question. Can you try to say me the answer? Answer is 3. Bindu, but it is wrong. No. First one, largest size is asking. My dear friends, the largest size is asking. Which is having the higher size? Second one, answer is 213 for the second one. That was shared by the Joshita. That is good, Nana. I minus is having the higher size, then neutral species, then the charged species. So 213 is for the second. Then what is the answer for the first one? What is the answer for the first one? Bindu, the answer is not 3, not 1. Not 1. What is the answer for the first one? What is the answer for the first one? For the first one, answer is S minus 2. Array, where you are getting confusion? Not maybe, it is correct for the, yes, because these are the isoelectronic species. Now already I said you these two are the isoelectronic species. This here you can see this has reached to the neon electronic configuration. This is also reached to the neon electronic configuration. This has reached to the argon, this has reached to the argon. But among the neon and argon down the group, argon is having the highest electronic configuration. Sorry, highest size. But here these two are the isoelectronic means, but the one which is having the higher negative charge is having the higher size, right? Now, one thing for the isoelectronic species, one thing you have to remember, isoelectronic species. What are the meaning of isoelectronic species? Means same number of electrons, same number of electrons in its shell. Same number of the electrons in its shell is known as the isoelectronic species. If n minus 3 if they are given, O minus 2 if they are given, next F minus, Na plus and Mg plus 2 and Al plus 3 if they are given. Now only the one trick you have to remember. This trick if you remember, easily you can predict the answer of the any question they may ask. For isoelectronic species, atomic number increases. What it will increase? Atomic size will be decreased. In the ఏదన్నా isoelectronic species ఇచ్చి దాని యొక్క atomic number increase అయితే దాని atomic size decrease అయితే blindly you believe. Good evening Prashant, good evening. Because here we are having this statement, if you remember, easily you can predict the answer. Isoelectronic species ఏదన్నా ఇచ్చి దాని size order అడిగితే only one thing you have to remember. What? Atomic number increases, size decreases. That's it. This atomic number is 7. Idanta 8. Idanta 9. This 11. This 12. This 13. So the size order will be in this manner. Okay. We can expect or we can say the question or we can solve this question in this manner also. Second one. Next one how to do? N minus 3. O minus 2. This is F minus. This is Na plus. This is next to Mg plus 2. Next is the Al plus 3. Now how we can do? Now we see. Here this is N minus 3, right? N minus 3 nothing but electrons are 10. Protons are how many? Electrons are 10. Protons are 7. This one electrons are 10. Protons are 8. Here the electrons are 10. Protons are 9. Here the electrons are 10. Protons are 11. Here the electrons are 10. Protons are 12. Here the electrons are 10. Protons are 13. See, here the 3 electrons are unbalanced. 3 electron repulsion. Here the 3 electron repulsion high size. Here the 2 electron repulsion. Here the 1 electron repulsion. Right? Here the 1 electron or 1 nuclear charge. Nuclear charge size decreases. Good evening, Lasya. Good evening. Now here 2 nuclear charge plus 2e. Here the plus 3e nuclear charge. Higher the nuclear charge, what happens? Higher will be the attraction and the size will be decreases, right? Size will be decreases. Clear? Now in this manner, the size will be decreases. Right? This is about the nuclear charge. But when it comes to the same thing, if you go for the which one? S minus 2, Cl minus, K plus, Ca plus 2. In this manner also, what I said, if the atomic number is increasing, Z is increasing, what happened to the atomic size? Atomic size decreases. S minus 2 is having a higher size, Cl minus and split. Why? Here the electrons are 18, protons are 16. Here the electrons are 18, protons are 17. Here the electrons are 18, protons are 19. Here the electrons are 18, protons are 20. Right? Is it clear? For the isoelectronic species, the size order, is it clear? Or still you are having any confusion? Still you are having any confusion, or is it clear? I hope it is clear for you. I hope it is clear for you, or still you are having any confusion. May I know, is it clear or not? If it is clear, once you say me yes, so that I can move to the next question. Next concept, ionization energy. The next concept, ionization energy, I can move. Yes, clear. Done. If it is a clear, we can move to the next concept. The next concept that we are having, ionization energy. Right. Good. Next concept that we are going to see, that is ionization energy. Now, what is the meaning of the ionization energy? Now, this ionization energy also, whatever we have expected the general trend, it is not following for the which one? Only for the few elements. Only for the few elements it is not following. But the remaining all it is following. The same trend it is following for the all. What is that? The left to right we have expected. The left to right we have expected ionization energy should be increased. Our ionization potential should be increased. Right? What is the meaning of the ionization potential or the ionization energy? Right. Definition of the ionization energy or enthalpy. Ionization energy or enthalpy. It is the minimum energy required. The minimum energy required to remove the outermost electron, from an isolated gaseous atom in its ground state. Clear? In its ground state or in its gaseous atom. from its gaseous atom in its ground state is known as the ionization energy. See, ionization energy means first ionization energy. Suppose X gas it is there. After removing the one electrons in that X gas, now it will become the ion. Now this one we call it as a delta H1. Delta H1. Now you see here from X gas we have taken by the removing of one electron. By the removal of one electron, now it will become the delta H1. Then after that, from this X ion gas, this unipositive ion, from this again if you want to remove the electron means we requires higher energy. Why we requires higher energy means, now you can see just an example I will explain for you. Best example I will go with the carbon. Normally the carbon valency electrons we are having it is carbon 2s2 2p2 means the electrons it is better will go to the protons it is having the 6, electrons it is also having the 6. Okay, then here the nuclear attraction is somewhat less, very fastly it can give the electron. When it the very fastly it has given the electron, it has reached to the 5. This one we call it as a IE1. IE1 means ఇక్కడ చూడండి ఆల్రెడీ ఒక ఎలక్ట్రాన్ ఇచ్చిన తర్వాత protons are 6, electrons are 5. Means one proton is unbalanced with the electron means it will express the high nuclear charge. Nuclear charge ante this nucleus is expressing the high nuclear charge means this valency electrons are strongly attracting towards the nucleus. When the valency electrons are strongly attracting towards the nucleus, why the electron will be given easily? No, it will not give easily. So that's the reason we have to supply the more energy. Here if I was supplying the 100 kilojoules of energy or 100 volt of electron volt of energy, here with the 100 electron volt of energy if I was applied to the unipositive anion or unipositive cation, then the electron will not be given easily because here the nuclear charge is increased. Nuclear charge increased, valency electron will be attracted towards the nucleus strongly. That's the reason we have to give more than this one. Arbitrarily I was giving some 200 electron volt. Means compared to the IE1, IE2 is having the higher energy, right? IE2 is having the higher energy. This is known as the I. Now we'll see how the IE1 and the IE2 will be varies from the left to right. From the left to right, how it is varies. Now we'll see. Here, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and the neon will take. Right? The expected left to right we know, left to right atomic size decreases. Atomic size decreases means Z. Nuclear charge, nucleus charge. Z effective or nucleus charge. Z effective increases, nuclear charge increases. Z effective means nuclear charge. Nuclear charge increases. So ionization energy increases we have expected. This is our expectation. Then the expectation order will be in this order. The expected order we got to know that with this one. But actually the expected order this one, but actually it is not correct. This is wrong. Why it is became wrong? Because here lithium and the beryllium case if you see, lithium it is having the 2s1 electron. Next order we will get it as a boron, then after that the beryllium. Sir, why it is happening like that means, now you see, we know the completely filled orbitals and the half filled orbitals. Completely filled orbitals and the half filled orbitals, right? Now what is the meaning of the completely filled? For the S is completely filled. For the P, this is P3 and this is a P6. This is a P6. Right? P6 orbital is more stable than the P3. P3 is more stable than the any other P1, P2, P4 and the P5. These are the stable electronic configurations for the P. When it comes to the which one? For the boron, we are having the 2s2 2p1. This is 2s2 2p1. Right? When it comes to the beryllium, 2s2 2p, sorry, this is 2s2, right? This is completely filled electronic configuration. Due to the completely filled electronic configuration of the beryllium, if I was to remove one electron, it will become unstable. Making the stable one unstable requires higher energy, right? But when it comes to the boron, if I was to remove this one electron, it is reaching to the stable electronic configuration of the S. It is reaching to the stable electronic configuration of the S. If it is reaching to the stable electronic configuration of the S, then if it is reaching to the stable electronic configuration of the S, then it requires lesser energy than the beryllium. Making the stable one unstable requires higher energy. Making the unstable one stable requires the lesser energy. That's the reason this concept or this order it has came. Right? Then after that, after the beryllium, we are having the carbon. Next we have expected the nitrogen should come. But actually it has came the oxygen. Actually it has came the oxygen. Then after the nitrogen and the fluorine. But here why the nitrogen has came? Nitrogen it is having the half-filled stable electronic configuration of the P. But when it comes to the oxygen, it is having the 2p4. Right? Now here this is a half-filled stable electronic configuration of the nitrogen, making the stable one unstable requires higher energy. But here the oxygen, if I was removed one electron from here, very fastly it will reach to the half-filled stable electronic configuration in this manner. Means making the unstable one stable requires lesser energy. Making the stable one unstable requires higher energy. That's the reason this is our expected order. This is the correct order for the which one? For the 3D series elements we are having. I hope it is clear for you about the ionization energy. I hope it is clear for you. Is it clear? For everyone, is it clear? Or still you are having any confusion? It is clear or still you are having any confusion? It is clear for everyone or still you are having any confusion? Right. Now, okay. Now, top to bottom if you see. Top to bottom. Top to bottom if you go. Top to bottom if you go. What happens? Now the atomic size. Top to bottom if you see. Atomic size will be increases. So the ionization energy will be decreases. Okay. For the top to bottom there is no any some variation in the ionization energy. It is good. Good evening. Good evening, Lasya. Good evening. Right. Right. Now, here I want to give you one question for you so that we'll have some idea about this concept. Let me check the question. Now, here one good question they have given. What the some configuration they have given? Right, some configuration they have given. One neon 3s2 3p1. Right. Second one neon 3s2 3p3. Right. 3 neon 3s2 3p2. Right. Fourth argon 3d10 4s2 4p3. Right. Now in this which of them having high ionization energy you are asking. Which of them is having the higher ionization energy? Which of them is having the higher ionization energy? Now same. Which of them is having the higher ionization energy? Electronic configuration they have given. My dear friends, try to do it by your own. Okay? Don't depend on the Google or any other source. It will decrease your thinking ability. If you don't know, try to ask me. I am ready to explain. But don't depend upon the any other gadgets or anything. Either it may be the chat GPT or anything. Answer is 4. No, Ishwant, once you cross check the answer, if you don't know, give me the question mark. Sir, I don't know the answer, sir. If you don't know the answer, give me the question mark. I am ready to explain. Answer is 2. Why, Bindu? May I know why the answer you have chosen it as a 2? May I know the element name? May I know that element name? May I know that element name? Good, 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 good. Good, Bindu. Answer is 2. Answer is 2. Why the answer is 2? Because this is neon 3s2 3p1 means the atom, this atom electronic configuration for is for aluminum. Now neon 3s2 3p6 means this is phosphorus. Neon 3s2 3p2 means this is silicon. Okay. Now this is the argon 3d10 4s2 4p3 means this is total atomic number is 33. 33 is arsenic. Now write like this. First Al will come. Then after that silicon will come. Then after that phosphorus will come. Exactly below to the phosphorus arsenic will be there. Now we know, right, left to right, what it will happen? Ionization energy will be increased. So and the top to bottom ionization energy decrease means the phosphorus is having the higher ionization energy. Phosphorus electronic configuration is 2. Right? Is it clear? The answer is 2. That's it. This one is aluminum and this is a 3 and this is a 2. Phosphorus left to right, what it is happening? Ionization energy is increasing. Top to bottom ionization energy is decreasing. Exactly to the phosphorus. Now arsenic will be there, but top to bottom ionization energy will be decreased. So the answer is 2. Answer is 2. Okay. Next question I will write. Now try to say me the answer. Next question. What is the next question? Now 1s2 2s2. Second is 1s2 2s2 2p3. Right? Third is 1s2 2s2 2p4. Fourth is 1s2 2s2 2p6 3s1. What is asking? Which one is having high IE1 as well as which is having high IE2. అయనైజేషన్ 1 దేనికి ఎక్కువ, దాని తర్వాత IE2 దేనికి ఎక్కువ? Now sim. 2 questions are there in this. For the which one the IE1 we are having? Next. Next one, for the which one the IE2 is having high? Think and give me the answer. If you don't know the answer, try to give me the question mark. I am ready to explain. Answer is 3. Bindu, once again you cross check. Once again you cross check. First you say me Bindu gave the question mark. Ramulu gave the one. Ramulu once again, sorry, Yashwant has given the one. Yashwant once again you cross check. Yashwant once again you cross check the question carefully. Once again you cross check the question carefully. NA fourth option. Which one? Joshita, I was asking the among the 1, 2, 3, 4, which one is having the IE1 first? Then after that, which one is having the IE2? Which one is having the IE1? Which one is having the IE2? Lasya is giving question mark. Srinitya is giving 4, but it is wrong. Now listen, I will explain. Now listen carefully. Here, first option he has given. What is the first option he has given? The first option, now the first option 1:2, 2:2. 1:2, 2:2 is nothing but 1:2, 2:2 if they have given means 1:2 and the 2:2 is nothing but which electronic configuration? 1:2, 2:2 is of which electronic configuration, may I know? May I know 1:2, 2:2 is of which electronic configuration or which atoms? Which atoms electronic configuration? Which atoms electronic configuration? 1:2, 2:2 is of the beryllium, right? 1:2, 2:2, 2p3 is of the nitrogen. 1:2, 2:2, 2p4 is of the oxygen. Now 1:2, 2:2 is of the sodium, right? Now here the compared to the beryllium, nitrogen and oxygen and the sodium. Now you see here this is a beryllium, here it is a nitrogen, here it is a oxygen and here it is a sodium, right? In the electronic configuration. But electronic configuration top to bottom among the oxygen and the nitrogen is having the higher size, but the sodium top to bottom ionization energy decreases. Then the sodium is having the first IE. Nitrogen is having the first IE. So option number 2. Option number 2 for the IE1. Option number 2 for the IE1. Then IE2 we'll see. IE2 means here what are the electronic configurations we are having for the IE2? What the electronic configuration they have given for the IE2? First one, this is a A. A is 1:2, 2:2. Right? The first IE means after the removing of one electron from this one will become 1:2, 2s1. This is IE1. Now it has reached to the which one? Lithium electronic configuration. Then B, 1:2, 2s2, 2p3. Now after removing the one electron, 1:2, 2s2, 2p2. Now this has reached to the which one? Carbon electronic configuration. Now C1, 1:2, 2s2, 2p4. After removing one electron, 1:2, 2s2, 2p3 means this has reached to the nitrogen electronic configuration. D, 1:2, 2s2, 2p6, 3s1, right? Now if I was removed one electron from here for this one, sodium configuration, it is reached to the neon electronic configuration, right? 2p6. Now you see, among the nitrogen and neon, which is having the higher electronic configuration? Neon is having the higher electronic configuration. That neon electronic configuration is representing for the sodium. That sodium is for the which option? The sodium is of the fourth option. So the second ionization energy is more for the which one? Sodium. Is it clear? Or still you are having any confusion? Clear Ainda? Or still you are having any confusion? Is it clear or still you are having any confusion? Still you are having any confusion or should I explain once again? Should I explain once again or is it clear? Right. Should I give the more questions on it? Should I give the more questions on it? I will give you one question. So based on that, it will be clear for you. I hope. I will give you one question. Now with that question, I will once again, I will same question only. The same type of the question only. I will give you. Now here the one atom 1s2, 2s2, 2p5 electronic configuration it is having. Okay. Now right. Now the B it is having 1s2, 2s2, 2p4. C it is having 1s2, 2s2, 2p6, 3s2. Now D it is having 1s2, 2s2, 2p6. Now E it is having 1s2, 2s2, 2p6, 3s1. What is asking? Now arrange them from the lower to higher. Now ionization energy of them from higher to lower. From higher to lower, arrange. From the higher to lower. Which one among this all is having the higher ionization energy? Which one is having the higher ionization energy? Now you have to say. Now arrange them the ionization energy from the higher to lower. Right? Order you have to say me. Order. Like we are having the A, B, C, D, right? Like that. Like that you have to say me. Like A, B, C, D. Like A, B, C, D, you have to say me. Like A, B, C, D order you have to say me. Like A, B, C, D order you have to say me. Now order you have to say me order. D, A, B, C, E. D, A, B, C, E. You are saying some of them are saying D greater than A greater than D is nothing but neon. Okay. A is nothing but fluorine. B is nothing but oxygen. C is nothing but magnesium. C is nothing but magnesium. And E is nothing but what? E is nothing but sodium. Right? Now D is I. Next to A. After the A we are having B. After the B we are having C. C after E. No, C. Magnesium and the sodium. Magnesium it is having the 3s1. Sorry, sodium it is having the 3s1. Magnesium it is having the 3s2, right? Now it is having the higher ionization energy than the, so the DABCE. DABCE. Who has said the DABCE? Now Yashwant has said the correct answer. DABCE. See, this is sodium, right? E. Now sodium. This is which one? Magnesium. Compared to the sodium and the magnesium, left to right, ionization energy increases, right? Is it clear? Is it clear? Or still any confusion? D, A, B, C. Ah, D, A, B, C. Good, good, good. Good, good. Everyone good. Right, right. Now, should I give the next question or we'll move to the next concept? We'll move to the next concept. Right, right, right. Right. Good, good, good. So in that manner, they will ask you the question. So you have to be very careful. Right, right. Okay, fine. The next concept we are going to see, it is somewhat it is somewhat complicated type. Two concepts we are having. That two concepts we will clarify it. Then after we'll do the number of questions, because tomorrow is only the question session only. No, 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 no. My dear friends, first let me finish the content. Tomorrow, Saturday itself, you are having the exam, right? So that tomorrow is a session only. Total question session only. I will bring the beautiful questions to you, so that tomorrow we'll do entire questions only. But first we'll clear the content. Whatever the misconceptions if you are having in the content, that first we'll try to make it clear, so that tomorrow we'll do total questions only. Total. Okay. Okay, you are asking the questions, right? So better I will give you one question, so that you will also be satisfied with that. Now, right? Okay. Now the answer for me here, the F minus F plus O plus N plus and C plus. Among the 1, 2, 3, 4, among the 1, 2, 3, 4, which is having the higher ionization energy and its order? Which is having the higher ionization energy order? Ionization energy order. 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 Which is having the higher ionization energy and its order. Once again, you cross check and say me the answer. Simply don't say me the answer. Once you cross check and say me the answer. No. 1 greater than, 2 greater than, 3 greater than, 4 is wrong. 1 greater than, 2 greater than, 3 greater than, 4 is wrong. Wrong, wrong, wrong. 1 greater than, 2 greater than, 3 greater than, 4 is wrong. 1 greater than, 3 greater than, 2 greater than, 4. 1 greater than, 3 greater than, 2 greater than, 4 is also wrong. It is also wrong. 1 greater than, 3 greater than, 3 greater than, 2 greater than, 4 is also wrong. Wrong. Next, any other order? Any other order? That is wrong. 1 greater than, 3 greater than, 2 greater than, 4 is wrong. Already I explained you right here, it is wrong. 1 greater than, 3 greater than, 2 greater than, it is wrong. 1 greater than, 2 greater than, 3 greater than, 4 is also wrong. 3 greater than, 3 greater than 4 greater than 2 greater than 1 is also wrong. That is also wrong. Now listen. Now listen. Let me explain. Now see, I will explain. F plus O plus N plus and the C plus, right? Now you see. Here actually the order will be. Now the actual order will be 2 greater than 1 greater than 3 greater than 4. This is a correct order. This is a correct order. 2 greater than 1 greater than 3 greater than 4. 2 greater than good. 2 greater than 1 greater than 3 greater than 4 is a correct. Why? Because now you see here this F plus means it has reached to the oxygen electronic configuration. Now O plus means it has reached to the nitrogen electronic configuration, and N plus means it has reached to the which one? Carbon electronic configuration. C plus means it has reached to the beryllium electronic configuration. Now for this one we have to cross check the ionization energy. We know nitrogen is having the higher ionization energy, then oxygen, then carbon, then after the beryllium, right? Right? Among this one, nitrogen is representing the O plus. O plus is 2. Then after that, oxygen, right? That is 1. Then after that, 3. Then after that, 4. That's it. Is it clear? This is the answer. Is it clear or still you are having any confusion? Is it clear or still you are having any confusion? Simply you should not check. Simply you should not check the answer by seeing the fluorine, by seeing the oxygen, by seeing the nitrogen. You should not predict. You have to see the charges also. You have to see the charges also. Charges you have to see after the charges, if you have eliminated the electron, for which electronic configuration it is reaching. Then after that, all the things you have to cross check and you have to finalize the answer. Now, next one. Next one. The same thing for this one only. F plus 2, O plus 2, okay? F plus 2, O plus 2, N plus 2. Now say me among the 1, 2, 3, which is having the higher order? Now say me the answer for it. What is the answer for it among the 1, 2, 3? What is the answer for it? 2 greater than 3 greater than 1. 2 greater than 3 greater than 1. Now here F plus 2 means it has reached to the nitrogen. O plus 2 means it has reached to the which one? Carbon. N plus 2 means it has reached to the beryllium. Then clear? F plus 2 means it has reached to the nitrogen. O plus 2 means it has reached to the carbon. It is reached to the beryllium, right? Nitrogen it is having the higher than the carbon, right? So the 1 greater than 2 greater than 3. 1 greater than 2 greater than 3. Not 3 to 1. 1 greater than 2 greater than 3. 1 greater than 2 greater than 3. This is a correct answer. 1 greater than 2 greater than 3. Right. 1 greater than 2 greater than 3. Now next one question I will give you. Now for the now the wow. Next one, the five five ionization energies are the five ionization energies are plus 500 joules. Second one 600 joules. Third one 7500 joules. Clear? Then next one we are having the some 15,000 joules. Clear? Next will be the some 20,000 joules. For the which electronic configuration? Now it will applicable. The five ionization energies are given in this manner. This is IE1, IE2, IE3, IE4, IE5 respectively. This is respectively. Which electronic configuration will be applicable? For which electronic configuration it will be applicable? First one 1s2, 2s2, 3s1, 3s2 will take 3s. Oh, sorry, this is 2p2. 1s2, 2s2. It is 2p2, right? Second one 1s2, 2s2, 2p. Wait. I will write the question. 2p4. Right? Next. 3, 1s2, 2s2, 2p6, 3s2. 4, 1s2, 2s2, 2p6, 3s1. Now you say the energy required to remove the electrons for the first ionization energy require 500 kilojoules of energy. Second one 600. Third one 7500. Right? Next fourth one 15,000. Next fifth one 20,000 joules respectively. Which among the following will be applicable? Which electronic configuration will be applicable? If you know the answer, try to say me. If you don't know, give me the question mark. I am ready to explain. If you know the answer, say me. If you don't know, give me the question mark. Okay, I am ready to explain. I will end the class by 8:40, like that. 8:40 I will end. If you know the answer, try to say me. If not, give me the question mark. I am ready to explain. Good, Bindu, good. Answer is 3. Answer is 3. Why? Because you can see. No. Answer is 3. Answer is 3. Yes, answer is 3. Why the answer is 3? Because now here what I was saying, now the first one, the energies are, first one is 500, second one is 600, third one is 7500. Now next fourth one is 15,000. Now the last one is at 20,000, right? In this manner the energies are there. Now here the electronic configuration 1s2, 2s2, 2p6, 3s2 is for the magnesium, right? Magnesium, due to the half filled stable electronic configuration, it requires 1. Then if you remove the 1 electron, it will reach to the 1s2, 2s2, 2p6, 3s1. 3s1, by removing one electron very fastly, it will give you which one? Neon electronic configuration, right? This neon electronic configuration is more stable. It requires higher energy to remove the electron. See, for the first ionization energy, second ionization energy, we are having the nominal energy. But very drastic change, it has been increased, right? Very much a drastic change. Very much a drastic change, it is indicating that it has reached to the noble gas. From the noble gas, removing of the electron requires a higher energy. Then it requires the higher energy means what? Then after that, if you from the noble gas, if it is remove, it will come to the 1s2, 2s2, 2p5. This 2p5 is of the fluorine. Fluorine also it is a higher electronegative element. It requires a higher energy. Then after that, it requires the 1s2, 2s2 and 2p4 also it requires higher energy. So actually this drastic change one we will get only for the configuration 3s2. If you remove the 2 electrons from here, it will reach to the 2p2 electronic configuration. That is carbon. For the carbon, this much a drastic change it will not be applicable. But when it comes to this one, first electron, but second ionization and only it should be the drastic change. But here the third ionization energy is a drastic change for the fourth option. So the fourth option is wrong. This one is wrong. Then if you remove the 2 electrons, but we are having the beryllium. But beryllium and here the which one? This one is a neon. 2 electrons if it is last, neon. But if the 2 electrons it is last, it is going to the beryllium. Compared to the beryllium and the neon, neon is having the higher ionization energy, right? Than the which one? Beryllium. Clear? That's the reason option number 3 is correct. Clear? Is it clear or still you are having any confusion? Still you are having any confusion or is it clear? Is it clear or still you are having any confusion? Right. No. You have to be very careful with the ionic radius. Right, among the ionic radius as well as the ionization energy. Ionic radius and ionization energy will play very crucial role. Right? Okay, fine. Now, next one. Next. Should I give the questions or should I better we'll see that tomorrow. Tomorrow two concepts we have left, that is a which one? Electron affinity as well as a which one? Next one electronegativity is there. Electron affinity, one thing you have to remember, just you remember electron affinity means electron affinity is nothing but tendency to gain the electron, the minimum energy released when the electron is added to the neutral or isolated gaseous atom in its ground state. Here the first electron affinity is always negative except beryllium and nitrogen and the neon. And the second electron affinity is always, this is negative. Now, is always positive, that is endo. Now, here the electron affinity order, if they ask, order for the second period elements. What are the second period elements? Lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine and the neon. See, this is having the negative electron gain enthalpy, this is positive, this is negative, this is negative, this is positive, this is negative, this is negative and this is positive. In this manner the negative electron gain enthalpies we are having for this one, right? But when it comes to the top to bottom, but the only the When it comes to the fluorine, chlorine, bromine and the iodine, we have expected the electron affinity order is fluorine greater than, chlorine greater than, bromine greater than, iodine. But actually fluorine being the smaller size, and chlorine being the larger size, it will accept the electron very fastly compared to the which one? Fluorine. Compared to the fluorine, chlorine will accept the electron. So electron affinity order we got it as chlorine greater than, fluorine greater than, bromine greater than, iodine. But the exception only we are having, this is one very good exception. You have to remember. Exception only for the which one? 16th group element, that is sulfur greater than, selenium greater than, tellurium greater than, polonium greater than, last is oxygen. This is a one exceptional electron affinity order for the oxygen. Oxygen family, this is only the order. And the rest all are same. The tomorrow, once I will explain the electronegativity. Then after that, we'll do the n number of questions because and it will be helpful for your Saturday's exam. Okay? Okay, my dear friends, any concerns you are having? Any concerns or anything? If you want to ask, you can ask. The remaining they can leave. That tomorrow we'll do the questions. Once the electronegativity concept it is there, that I will explain, and after that we'll do the questions. No. Okay, bye. Okay, bye, Nana. We'll see you tomorrow. Then we'll see you tomorrow. Okay, bye. Right. Bye. Okay, fine.